Hi everyone, welcome to this video. In this video, we are going to discuss next set of interview questions. These questions go a level deeper. Here, interviewers are not checking the definitions. They are going to check whether you understand the cost, reliability, and orchestration factors. So we will explain all these interview questions in a proper way. You can modify it in your own language, but you need to understand the crux of this question. So the sixth question is, why is fetching incremental data more cost efficient than performing full data loads? So this question looks very simple, but it actually revolves around how also cloud billing works. So in a full data load approach, every time a pipeline runs, it scans and processes the entire data set. But even if a new few records were added, as the data grows into millions or billions, you can't do the full load. In that particular perspective, the incremental loading processes comes to the play where it can help you reduce the processing cost and the efficiency of your pipeline. So in this project, we have used incremental data load technique, whereas we are fetching only new records from the Azure SQL database whenever the new inserts occur. This means the database query scans fewer rows. Now our logic app also has a recurrence trigger which runs on a particular interval, and when this logic app gets triggered at particular interval of time, this will basically find out the new records that that is basically inserted into the SQL database, and it is going to use the incremental column value, which is ID, and then it will compare it with the last process ID so that it can rectify which are the new records from the Azure SQL database. That basically reduces the compute cost, storage cost, and pipeline execution time, because if you load the entire data from the in every execution run, what will happen? A large chunk of data will enter into your pipeline, and sometimes if you are not using the large workloads compute, that also incurs a large cost, your pipeline will get failed. That's why incremental loading is a default approach in enterprise grade real-time pipelines. The next question we have is, explain the logic app workflow used in this project. So that logic app workflow which we have used in the project is pretty complex. So for that, you can basically go to the download code section where you can just install the installation and execution folder zip file. You can just extract it, and inside that you will find a file, workflow design using logic apps, where we have created an entire workflow of logic app. So the first thing that we have done is we have created a logic app, and then we have created a logic app user inside a SQL database so that our logic app can have an access to that. Then we have added a recurrence trigger, so that basically schedules a workflow. This logic apps automatically on a fixed schedule. Then it basically reads the last process record. So as you can see, a small JSON file is stored in the Azure Blob storage. So for that, we have created a JSON file by the name of persistent run. We have given initially we have given the value as last process ID 0. Later on, when the new data gets inserted, it will get updated. So your logic app knows which is the last process ID so that it can compare it with the new one, and only new records will be inserted in the further execution in the pipeline. So you can go through the entire documents. Although we have explained each and every pointer in detail, so don't worry about that. We have also added the answer of this question in the interview guide itself, so you can just go to it. Now coming back to the next question, which is, what happens if the logic app workflows fails for any reason while the data continues to arrive? Now this is a scenario based question, so I'll just continue reading this. In that case, when the logic app runs successfully again, will it process all the missed data? So the answer to this question is very simple. Now if you can answer it in a very good technical way, so you can say that if the logic app fails for any reason, incoming data is not lost, because Azure SQL database remains the source of the truth where it will have all the records, whereas the logic apps will have the information of the last process ID. So even if the updation gets failed, what will happen? New records continue to be inserted into the table. Now the logic app, when it gets fixed, it will basically update the last process ID after the successful execution. So there will be no data loss, no duplicate processing, and there will be the full recovery without manual intervention. So when logic apps gets fixed, it will successfully run, and then it will fetch only new set of the records from the SQL database. Then we have the role of Azure Data Factory in this project. So Azure Data Factory plays a vital role in this project. Now, why are we saying this? Because it plays the role of the orchestration and the data movement. In the as we talk about the orchestration, it basically orchestrate our Medallion architecture, and then in the first place, it basically act as a copy data pipeline. So what's happening in our project is, when we have the data, new set of the records in the Azure Blob Storage, we need to put that into hierarchical namespace or Azure Data Lake Storage. For that, we have the copy pipeline. So what it will do, whenever there is a new set of the new records in Azure Blob Storage, this will get triggered, and then it will basically, this ADF gets triggered as we have added the storage event triggers in our Azure in our ADF. That basically says whenever a new set of records lands in the Azure Blob Storage, just this pipeline will get triggered, and then it will copy the data from this file to this one. This is how the copy pipeline works in a pipeline. This separates the raw ingestion from the analytical ready storage. The second pipeline we have is notebook activity pipeline or an orchestration pipeline. So whenever a new data lands in ADS, we want the ADF to trigger our Medallion architecture, where we have three notebooks: bronze, silver, and gold. For that, we have used the ADF, which use the Databricks notebook node, whereas you can include your notebook pipeline, and then what it will do, it will basically execute your Medallion architecture automatically. You don't have to run each and every workspace on your own. So overall, what we can say is the ADF in this project ensure the data flow sequentially and consistently through the copy pipeline and the Medallion architecture as well. So we don't need to run each and every workspace. The ADF will handle all the things on your own. How is Data Factory triggered whenever a new file is added to the storage account? So that's a very good question. So as we have discussed, that Azure Data Factory basically gets triggered whenever a new data file lands in Azure Blob Storage. So for that, what we have done is we have added the storage event triggers in our ADF, which means this triggers will listen for the file creation in the Azure Blob Storage, and whenever a file lands in the Azure Blob Storage, this ADF copy pipeline will get triggered, and then it will copy the data file from the Azure Blob Storage to the Azure Data Lake Storage, and furthermore, now this makes the pipeline event driven and near real time, and it is fully automated. So you don't have to just copy each and everything on your own. This pipeline will copy and and move the file to the Azure Data Lake Storage on their own. Now coming back to the next question, which is why is a scheduling trigger not used in the Azure Data Factory in this project? So this is a very good question. So so what approach does interviewer use? So it does. So interviewer doesn't ask you a very simple question that what's the difference between this. He will also ask you the why approach from you, that why did you use this and why didn't you use this. So this is a question that is related to that point. So why is the scheduling trigger not used in Azure Data Factory? Why did you use storage event trigger? So what is scheduling trigger is? So you can start by saying that a scheduling trigger runs a pipeline in a fixed time intervals. For example, every hour or every day, regardless of whatever new data exists in. That means pipeline may run even when no data is available. Cost can increase as data volume. But in our project, as we have added the storage event trigger, this pipeline will get triggered only when there is an event in the Azure Blob Storage. That means whenever new data file lands there, this pipeline will get triggered only. So that's the one approach that we have taken up. So instead of scheduling trigger, we have used the event-based trigger. So with event-based, this pipeline got automatic, and then this design also ensured that pipeline is data-driven and cost optimized. The next question we have is, why did you use Azure Databricks for data transformation instead of ADF for mapping data flows? So this is a very good question, because we also have a node in the ADF, which is data flow. So in the ADF, in the data flow, what we do, we basically create a pipeline, and we can have the different components where we can join, transform, and do all other things. So why did we use Azure Databricks for converting and cleaning and transforming our data for the final workloads at the business intelligence side? Why didn't we use the data flows of ADF? So ADF mapping data flows are great for simple transformation. It's basically a UI based service in the ADF. So it doesn't use the code use cases. It's also a smaller pipeline. But in this project, we are implementing the Medallion architecture, data quality checks, deduplication, and reusable transformation logic. Whereas in the Azure Databricks, each medallion architecture layer, that is bronze, silver, and gold, is implemented as a separate notebook. So if we try to split the logic between ADF data flows and Databricks, the data flows cannot handle the complex data transformations. Whereas in the Azure Databricks, you can write a code which is basically compiled and strong enough to process, clean, and transform the data accordingly. Whereas data flow has some UI based use cases which you can't use in the Databricks. For example, if you want to use the open table format, you can't use the ADF for an extensive way. Whereas in the Databricks, you can just set up the iceberg or any other open table format which you can use inside it, and then you can have your workflow analyze and transform in the Azure Databricks. That's why we don't use the ADF. So ADF mapping data flows are good starting point for beginners, but for the enterprise scale pipelines, a Databricks centric approach is much used. Then we have other question that how does our pipeline ensure idempotency and avoid duplicate data processing? So this is a production grade reliability question. So interviewer will ask you whether you are capable of understanding the code or not. So what you can do, you can basically answer that. You can answer that at the ingestion level, the Azure Logic app fetches data incrementally using an incremental ID column. So in every run, only the records with ID greater than the last process ID will be ingested into the further execution, that is Azure Blob Storage. Now that guarantees no duplicate ingestion or idempotency. Then we have the processing level. So in the processing level, when you open the bronze layer code notebook, you will see we have the drop duplicates. So you in the project we have also explained each and every layer in detail. So you can just go to the video and then follow it accordingly. So in the first part of this Azure series, we have explained each and everything from the code in detail. You can go to it and then watch the content accordingly so that you can get a graph of what we are basically explaining. So in the bronze notebook, we have used a drop duplicate. So why is it important? That because it basically says that pipelines can be rerun. Upstream system may introduce the duplicates. Now, drop duplicates basically means that it basically follows the principle of idempotency and avoiding duplicate data processing. By removing duplicates at a bronze layer, we ensure that a clean, unique records move downstream in our pipeline to the business intelligence layer. So both ingestion and processing layer enforce idempotency. The pipeline can safely retry and recover from the failure. So these are the questions that we have discussed till this point. On the next video, we are going to discuss the remaining questions in detail. And by the end, you will have the better understanding of how you can answer this kind of questions in a interview. So these are the potential questions which we are explaining. The interviewer might ask you some other question which is not mentioned here, but you need to prepare for that as well. But from these questions, you will basically have a very good understanding of what you have done in this project on your own. So thanks for watching this video.